All right, we'll start this chapter off with a review on how we write and balance equations. Again, this is a topic we have covered extensively in the prep class, so I'm not going to go over it in any, super detail here. I'm going to do a basic review. If you are stuck, if this is something that you are having trouble remembering, this is a really key thing that we do over and over. So you can always search my channel for the videos where I do teach this topic from the beginning, or as usual, you can ask me questions, come to office hours, ask me in lab, those sorts of things. I'm always willing to help you. All right, so let's take a look here. Okay, so when we look at chemical reactions, we have reactants becoming products. Now, this is a really inconvenient way of writing a reaction. It would be really hard to write all this out. So, do we usually draw pictures like this? Not usually. However, when you take organic chemistry, you'll do what we call mechanisms, and you'll be doing lots and lots and lots of structure drawing to show how things move around to go from our reactants to our products and all the intermediates that occur. But when we talk about just a general basic chemical equation, we don't typically draw it out like this. Okay? What we get is something that looks like that. Okay? So we balance these. We have to satisfy that law of conservation of mass. What we put in is what we get out. Mass is neither created nor destroyed for a non-nuclear reaction. General, regular old chemistry, mass is neither created nor destroyed. Remember, we've got several designations here. We've got a G for gas, an L for liquid, an S for solid, and of course our AQ for aqueous. All right. So, as chemists, we use our nomenclature. I have some hydrogen gas and I have some oxygen gas. They react together to form water or dihydrogen monoxide. That's the way we talk. We don't say, well, I have some H2 and I have some O2 and I react those and I get some H2O. No, we speak in the language of chemistry. So when we are presented at first with a problem where we aren't given the equation, we have to start off, and that's our first step, is to convert or translate that statement into a skeleton equation. Once we have that skeleton equation, then we can balance, check, make sure that we're all good to go. All right, so the next few slides, I have several examples for you to try. What I would like you to do, I will give you the final answer, but if you just copy my final answer, that's not going to check your remembrance of this or your understanding. So you need to make sure that you can do this. So before you look at my answer, I do want you to pause or turn the video off and just go straight to the slides that I've posted on Canvas and try these and then come back and check your answers. All right? Because again, if you just copy what I do, you're not going to be successful going forward. You actually have to engage with the material and try it yourself in order to be successful. All right, so here's our first one. So again, before you look at my answer, stop, pause the video, try it on your own. Okay, first I'll give you the skeleton equation. Okay, so we've got our silicon dioxide, we've got our carbon, okay, we've got our carbon monoxide, and our silicon. Hey, now I'm going to add one more thing. You may remember from the previous class, sometimes above the arrows, we might have some stuff written that helps us understand a little bit more about the reaction. If I put a delta above my arrow there, that means it's been heated. You don't have to put that there. I'm not going to grade you down if you don't put it there, but I do use those symbols, and so that delta just lets you know, hey, this was heated. Okay? All right, and then our balance and 2. Okay? All right, so there's our first one. Same thing, stop, pause. First I'll give you the skeleton equation, then I'll give you the balance. All right, let's see how you did. Okay, and then this was done under UV, so I'm going to put that UV above my arrow here. Okay. All right, so there's the skeleton. And there's the balance. All right, here's one more. Okay, once again, pause, try it yourself. I'm going to first give you the skeleton, then I'll give you the balance. Okay, here's the skeleton. All right, there's our skeleton. Now for the balance. All right, so there's that one. Okay, now this last one I have requires you to write out two different equations and then to put the overall process together. Okay, so we've got one process. Let's see here, let's use this. Okay, is this one right here. All right, and then we have a second process right here. Okay, so first thing, I want you to put both of these into balanced equations. And then if you're not sure how to do the overall, then unpause and I'll show you. So first, pause, see if you can write the two stepwise equations first. Okay, let's see how you did. So I'm going to write out the two stepwise equations. Oh, I was going to try to do them in the same colors that I highlighted in. That one's too light. Let me switch this one. Let's see if that's better. I'm just going to go with black. That one is, the highlighter is a deeper color. The pen is a lot lighter. So I want to make sure you can read it. All right, here's the first one. Okay, I'll do this. Okay, and now for our second one. So you'll notice that what I've done is I've tried to line up the reaction arrows, okay? Okay, so I've done this because when we do an overall equation, now what we need to do is we need to cancel out anything that shows up on both sides of the equation. So you'll notice here, I've got sulfur trioxide as a product in equation number 1. And then I have 2 sulfur trioxide as a reactant in equation 2. Well, if something is a reactant and a product, it's going to cancel out, all right? Okay, sulfur dioxide only shows up in a reactant, oxygen good, the water good, the sulfuric acid good. So our overall is going to look like this. All right, so there is our overall reaction. So again, if you struggled with this, if equation balancing is something that you don't really remember how to do, or you're, realizing like, ooh, I need to review that. A few things you can do. One, you can find the videos where I teach equation balancing to an introductory level class. You can come to my office hours and ask me questions, or during lab, if there's some downtime during the experiment, you're always welcome to ask me questions then as well. Okay, so that is our review on equation balancing.